Hello everyone and welcome to the Thursday night C# 101 class. This is the final class, week number 6. So welcome guys. Before we get things kicked off, there's something I'd like to talk about real fast, and that is graduation from this class. Instead of just, finishing up tonight and saying, well, that's it, thanks a lot, have a good one. It doesn't quite work like that. There's going to be some days that are going to be set up for next week. And I will have those posted. I was hoping to have them posted by tonight, but UDK has been kind of a big thing getting all of that set up. So by tomorrow at some point, I'll go ahead and get those posted. And right now, I'm looking at doing 3 different sessions. So you can pick one that works for you time-wise. You can attend all 3 of them if you want. But the idea is that you'll come into the session, and we're going to administer a test. And you'll take the test. You must pass the test. You will know instantly as soon as the test is over if you have indeed passed or not. Java, it's open book, Ken, but it is a timed test. I mean, we can't really stand over you, and it's not like we can turn on all you guys' webcams and be like, close that book. Doesn't quite work like that. But it will be multiple choice, Wick. Just to keep things simple and to give fast feedback, or multiple guess, that'll be for Toastage. And once it's over, you'll, if you have any questions about anything that you missed, we will be here to answer the questions. If you fail the test, you can come back the next night and take it again. That's why I want to give 3 nights, or 3 afternoon/nights of this testing period. It is not going to be a difficult test. I know that this class has been a little difficult for those that are completely new to programming, when from time to time Nelson goes off on some of his fancy tangents to demonstrate a point to people that are in this class that know a little bit more than your 101 beginner. But the content that's going to be presented in the test will be 101 stuff. So for those of you that have C# experience, don't expect to be challenged in the test, please. Okay, remember we said from the very beginning, this class is for our beginners. So once you've passed the test, that's it. We'll get all of the information all put together, and you guys will receive certificates by the week after. We just got to get everything finalized, if you will, and make sure your attendance was good and all that good stuff. So there will be homework tonight. We'll talk about that as we approach the end of the class. So that's another thing that'll still need to be turned in by next week, and Gavin will talk about that when we get to the later portion of this class. So I think that's the only thing I wanted to mention. And also for those of you that haven't seen, the C++ class has gone live for registration. It will be kicking off on Monday, so just right around the corner here. We're going to be doing a free class on Monday and on Friday for week 1, but then after that week, all of the rest of the classes are member sponsor only as we continue. So there'll probably be quite a few more people in the Monday and Friday class. You are permitted to take both classes as always, so feel free to come back and listen to the content being presented again if you take the Monday class. Friday will be the second roll around for that week, and it will be an evening class on Friday. The C++ class is going to take our Monday C# 101 class time at 3 o'clock. The C# 102 class, which there will be a few of you guys here that are going to be interested in, that class is going to be Thursdays, and tentatively it is going to be at 7 p.m. at the moment, just letting you guys know. We're not going to be doing 2 of those classes per week. So we've got 2 C++ classes because of sheer demand, and again, trying to help people with different time zones. And the UDK class is now open for registration as well. Zach is getting the final stuff put into the calendar system, and he will be making a post as well. But you guys can go ahead and, get signed up for those. And again, you can take both classes if you'd like. Those class days are going to be on Monday. Monday will be the evening classes at 7 p.m. And yeah, these are all Central Time, so these are my time. And we're GMT -5 at the moment.
Yeah, but we're, of course, GMT
Plus one.
over here, so that's 1 a.m. for those of us in British summertime.
Yeah, but with UDK, we are, once again, trying to accommodate as many people as we can, so it will be Mondays at 7 p.m. Central, and then Thursdays it will be at 3 p.m., so 3 o'clock in the afternoon Central Time. And the dates are interesting with that one. It is a 6-week class, but there will be, because Zach, Angela, and myself will be up visiting Leonard here at the end of April. Whoop, can't wait for that to get here. And we'll be out of town. Basically, the UDK class will meet on the week of the 23rd, which is a Monday, but it won't meet on that Thursday. But then switch that around for the week after, where they won't meet for the Monday, but they will meet for the Thursday. So everybody will get their class, but there'll just be one day each week where the Thursday class will be pushed back, and the other one, the Monday class, will meet early and then miss the week after. All of that's going to be detailed. So anyways, there's everything that's going on at the moment. Tonight, we're going to be diving into object-oriented programming. We did get some outstanding feedback from students that were in the class on Monday that were new to coding, that felt like we took a huge step up with complexity this week. So brace yourself ahead of time. Though please understand, we don't expect to present you information about object-oriented programming and discuss classes and members, etc., and for you guys to walk away from this class going, I know object-oriented programming. I'm a designer. All right. It doesn't work like that. If you haven't seen the C# 102 class, that class is going to focus a lot more on object-oriented programming, and there will be a lot of design discussion as well as we work our way through those 6 weeks. If you have not seen the syllabus, I did make it available for a sneak peek over in the 3D Buzz Lounge. So take a moment and look at it if you're curious about what's going to be going on in our next class. But I don't want for anyone to get all uptight and scared about the content that's going to be presented tonight. It takes working in an object-oriented nature to become comfortable with it. And, for those of you that are beginners, you have no experience. And what were you going to add to that, Nelson?
Well, I was just going to say that object-oriented programming is a lot more about a mindset and a way that you approach problems. We're going to be going over the tools you can use in the language to actually express those things, but coming up with those solutions yourself is going to take time. It's not like learning an array or a list or an if statement, something that you can quantify very easily if you've learned it. It's going to be something that takes time to sort of being able to apply these different language tools.
That's right.
So don't be discouraged if you listen to the technical details of what we're going to be explaining and you go away from the class thinking, well, okay, now I know what a class is, blah, blah, blah. Don't be discouraged if you can't turn around and create a proper design out of that, because that process of creating a design is something that's very organic and will take time to sort of understand.
That's right. So, yeah. All right. I think that's everything we needed to announce. We're 8 minutes in. And so let's get rolling, Nelson.
Alrighty. So code.
So first of all, just the idea of object-oriented programming. I know in the syllabus we've got concepts and features, and we mentioned encapsulation, polymorphism, and inheritance. Those are really just mentions, not an exploration in 2.
Right. Okay. Object-oriented programming, like I said previously, it really is an idea that, or a concept, or a way that you will look at how your program executes. And conceptually, object-oriented programming is about thinking about your variables in terms of objects. And what is an object? An object is a thing that contains state and behavior. For example, an object that we have been using quite often here, integer. Now in C# and in Java, and in dynamic languages such as Ruby and JavaScript and PHP, actually not PHP. PHP is weird. Integers are objects. And this is an example of, I've created an example of an object. And what this is a variable that contains state, in this case the value 10, and it also contains behavior. Now, if we were to, inside of Visual Studio, type out our identifier and follow with a dot symbol, you'll see a variety of behavior that this object can perform. Really, we've only talked here about the toString method, for example, but the point here is that all these methods are behaviors that this object exposes. So that's a very simple example of what an object is. A more complex object might be a list of, or generic list, in this case, list of int. And you'll see right here that this object behaves a little bit differently than the integer object. And the reason it behaves differently is in C#, these kinds of objects do not have literal syntax. Integers, decimals, floats, doubles, characters, strings, and booleans, I'm probably forgetting a few, but still, all have literal syntax built into the language. So I can say int number equals 10. This is valid. The reason this is valid is, although int number is an object, we can assign it to this literal syntax, in this case, just the literal 1, 0 to indicate the decimal 10. And C# supports this built-in. It knows that the 10 value turns into an integer object, which is why, for example, we can say 10 dot and get the same list of members that we did previously. Now, C# also has built-in literal syntax for strings, and so on. So these are all examples of objects, but we don't instantiate them directly. We don't create them explicitly. They're implied based off the syntax because the C# language specification has these literal types built in. Now, list does not have a literal type or a literal syntax. What we have to do here is what we will commonly be doing for all of our objects in .NET. We're instantiating it. We're saying right here on the left side of the definition that this is going to be the type of this variable is going to be a list of int, and it's going to be called list. And on the right-hand side of this expression or this definition, we see the initializer, in which we use the new operator to instantiate, to create a new list and assign it to our variable. This is commonly how we will be creating objects. So remember, just to go back to the definition of what an object is, an object has state and behavior. The list object, for example, has behavior, and it has state. And the state and behavior of the list object is local to the variable itself, which is awesome because that allows us to create as many of these lists as we want to perform any sort of operation we might want to do with multiple objects of the type list. Now, so is everybody kind of at least good or comfortable with the concept of what an object is and how it relates to variables?
And I do want to throw this out real fast, just a reminder. Please make sure you are in BuzzNet if you are logged into the webinar. That is a requirement.
And if you can't get in, go ahead and poke us on the questions panel.
That's right. And again, that is at buzznet.3dbuzz.com. It is a requirement. Okay, continue.
Alrighty, so I went ahead and defined objects, and the concept of an object being a variable that has state and behavior is ubiquitous across all object-oriented programming or all languages all languages, period. Even in C, which isn't an object-oriented language, specifically it doesn't have any facilities for object orientation, or languages like JavaScript, which doesn't have any familiar facilities for object orientation, you can still express object-oriented programming because you really have these two things, these state and these behaviors, and then you have these objects. But so people in C were writing programs that didn't have classes and didn't have a built-in concept of object-oriented programming in the language, and they found themselves really wanting to have a way to define how an object should behave without actually defining the object. They wanted to be able to define a template for an object and have that template be used to create instances of that object. Now, because C and then C++, which was the realization of that, and now C#, because these are statically typed languages, that template must be defined beforehand before you use it. So I want to point out, though, that if a language such as JavaScript doesn't support what I'm about to show you, it doesn't mean that it doesn't support object-oriented programming. It means that it doesn't have special built-in language features that allow us to express it easier. With C# and all other .NET languages, the mechanism that you express object-oriented programming is primarily going to be through the kind of type called a class. So we've talked about types before, and we've talked about how a type, specifically a closed type, but we haven't talked about those yet, is anything that we can use as a type of a variable. So every variable has a type, and almost every type allows you can create a variable out of almost any type of type. And there are a variety of different kinds of types that we can use. We explored enumerations in the last class, which were a kind of type that we could use to create, these cool little variables and stuff. But the enumeration happens to be the least versatile kind of type in the .NET framework. The kind of type that we will be using here quite regularly is called the class. And we've seen a class already, right here, class program. But I kind of want people to ignore this part for now, simply because class program and the fact that main is static, which is something we'll be talking about later, does sort of change the way that this class is used. It's not used in the same way that we're going to be using other classes that we create in this class. So I kind of want people to ignore this for now and start thinking about classes, as an entirely new concept. And basically, what a class lets us do is a class lets us define a type, which is the class, that represents a blueprint for how the objects created from that class behave. It doesn't actually do anything until you use the class to instantiate an object, meaning a class definition isn't code that's going to execute when your program starts. Unlike what we've seen with main so far. When we use main gets executed line by line. But think about how you have functions, or methods, sorry. The existence of this method doesn't mean that this code is going to be executed necessarily. But what will happen is during the execution of main, other code can invoke this method 0 to many times. Same thing is true for a class. When I'm going to show a syntax example of a class here, and I just want to point out that what I'm typing doesn't represent code that's going to be executed when the program launches. The birds and the bees of C#.
Yeah.
What? I don't get it.
That was when you were talking about C.
Okay. So how do you define a class?
Well, before you get in defining, in all fairness, there's still about 3 people that have not come into BuzzNet. If you do not get your butts in here in the next couple of minutes, I will be dismissing you from the webinar. Again, it's a requirement. All right, continue, Nelson. Thank you.
Okay, so classes. So the way we define a class, well, you see an example in line 10, but I told everyone to ignore that. You start with the keyword class, not surprisingly. Then you give it an identifier. And this identifier should be in Pascal case because, well, that's just how it should be. All types should be in that case. Types should not start with a lowercase. So we can give it an identifier. And this identifier is going to be how we can reference our type throughout our program. In this case, I'm going to create a car type. So I'm going to give the identifier of this class the name car. With
oh, come on, Nelson. We did car Monday night. Let's make the content different. Can you do a dog or an animal or a pony? Oh, there you go.
Oh.
Okay. So we have a class, and we've given it a name. We've given it an identifier, and that identifier is in the proper casing. Now, what comes after that is, again, not surprising, we open up a block. Now, again, this block doesn't represent executable code like a method does. Instead, what goes in this block is very interesting and very important to understand. What goes in the block are what are called members of the class. The members of the class are the data and the state that will be carried around with objects from this class throughout the object's lifetime. So for example, what I could do, ignore the modifier public for now. I'm going to say public string name. Now what I've done here is I started with, I've created what's called a field. And a field is like a variable, but it's a little bit more interesting than just a normal variable. It behaves just like a variable, but it's always going to be specific to the instance of the class that we're working with. So it's very important to understand that this name field will actually, if we had 10 ponies, we would have 10 names, for example. This is a member, meaning it's owned by the parenting class. And we start a field definition with the modifiers. In fact, we start all members with modifiers. And there's a variety of different modifiers we can use. In this case, I'm using the accessibility modifier called public, which we'll talk about the other accessibility modifiers shortly. The next thing that follows after 0 to many modifiers in your field definition, you give it a type. Because you can think of this field like a variable, a variable needs a type. The type of data that can be stored by this field needs to be defined because, well, we're working in statically typed language. Just as you couldn't, in main, you couldn't, create a variable without a type. Just like that, you can't create a field without a type. Field needs a type. Field also needs a name. So this name is going to be how you reference this field, or specifically how you reference this name member. And the conventions of member names are difficult, and we'll be getting more into the conventions of member names later once we have a few more different kinds of members that we can play with. But for now, we're going to leave this as a capital N-A-M-E. So again, this is a field. And the field is data or state that will be carried around individually by every object of this type. So if I go ahead and nuke main, what do people think the output of this program should be?
A bolt gun.
A what?
Never mind.
So if I run this program, we get RD followed by F. Okay, so what's going on here is Ahair70 asks a good question. He asks, what's the difference between public string name and public string name? There actually is no difference. String is a type of System.String. This only works when the system namespace is being imported, but the system namespace is almost always imported. The string keyword, you can notice it's a keyword because it's blue, is a part of the C# programming language. It's part of the specification that says anytime the string keyword is seen, to effectively replace it with a reference to the System.String type. So these two variables, these two fields are functionally equivalent because they're representing the same type. Just like int is an alias for System.int32, float is an alias for System.single, bool is an alias for System.boolean. The built-in data types are just going to be aliases out to the data types in the BCL. However, I do not recommend using this. For any of the built-in types that have a corresponding keyword in the C# language, I would highly recommend using the keyword version instead. And the biggest reason is readability. seeing the blue highlight on the string and the int and the bool, and the fact that it's lowercase really shows off at a glance that you're using a built-in type. By doing something different where you have an uppercase teal-colored variable, unless it's another built-in type that you recognize, you might think about it differently when just glancing through code. So this is significantly harder to read than this if I was reading through code very quickly.
And particularly if you, say, had a method that doubled whatever you put into it, as an example.
Yeah. Okay, so what's going on right now is really important. And basically what we have here is the fundamentals of object-oriented programming. What we've done is we've created a template, and we've called it Pony. And this template has a single field or a single member in it called name. This template is just a blueprint. It doesn't represent, I mean, it can have executable code in it, but by default, it's not going to, well, do anything unless we call upon it to do something.
It's just a blueprint.
Now, right. I mean, you can't drive a picture of a car.
Well, let's not do picture of a car. That's kind of odd. A blueprint,
well, blueprint
for a car, or blueprint for a house.
X-ray of a horse.
Anyway, so this is a template, and well, not to be. When I say the word template, please don't confuse it with the template, which is a C++ construct, which is completely 100% unrelated to what we're talking about. So yes, when I say template, I'm referring to blueprint, or in this case, a type. So we've defined here a type that we can reuse and reuse and reuse, but there's only one thing we can do with types, generally speaking. The one thing we can do with types is we can instantiate them. That's what the new operator does. By specifying new followed by an identifier that identifies a class, we have effectively instantiated that class and turned it into an object. We've asked the computer to give us not a copy, but we asked the computer to go out and build an object for us that follows the specifications of the type we defined, and then return it back to us in a way that we can alias out into our own variables. Now, by aliasing them out to our own variables, we now have 2 bits of functionality that can be stuffed with state and acted upon independent of each other. So we've effectively made the concept of a pony something that we can reuse throughout our application in different contexts without stepping on our own shoes or our own feet. If we, like, for example, if we were to have just a variable, or specifically a field in program that represented just a single object, we wouldn't be able to reuse that object in different scenarios. But by creating a class, we can now reuse this functionality all over our program. So are there any questions yet? Why would you use a class to initialize a string instead of just typing out the string? That's a good question. We'll get into that. The public string name or field in the class is only one of the things we can put in the class. In fact, we can have as many different fields as we want.
Any other questions?
Okay, fine. Well, I guess nobody has any more questions. So I'm going to go ahead and move on to...
Well, before you expand on that a little bit, do you want to talk a little bit about, because there's some basic encapsulation going on right here.
Yeah. I mean, in a sense,
in a sense, that's why I said very basic.
We've created more value. First of all, we've created a lot more value in our program by being able to encapsulate an attribute into an object instead of having that object as a free-floating variable, which will cause a lot of issues. which I can go ahead and demonstrate. But we did have one question pop in.
Okay.
Once we make an instance of a class, is there any way to get rid of it? In C#, there is one way to get rid of an object. Unlike C and C++, and Objective-C, I'm pretty sure, and a variety of other native languages, C# is managed, and it has managed memory, which means that the objects we instantiate in C# are not going to be deterministically destroyed by ourselves. Instead, the runtime will decide when those objects should be gone. Elevating asks if there is no destructor. Yes and no. There is a special, super magical, awful, horrible, disgusting thing called a finalizer, which does not behave in the same way as a destructor at all, and should not be used like a destructor. In fact, it really shouldn't be used other than to inform somebody that they didn't dispose of an object prior to it being collected. But yeah, there are no destructions in C#. There is no delete keyword in C#. There is no way to inform the environment that you no longer want to use an object other than dereferencing it or making the reference go away, not using the reference. After doing line 26, at any point between line 36 and the end of the program, the garbage collector, the little component that sits on the CLR and watches memory as your program executes, will decide that because this object is no longer referenced, it's going to go ahead and collect it for us, or it's going to go ahead and destroy it. There are ways to control the GC. Not that you would want to, except for in very advanced situations, but we can actually force a collection if we wanted to. By doing GC dot, and then we have things like wait for full GC complete, wait for pending finalizers, and so on. There are ways to control the GC, but we wouldn't want to control the GC.
But let's go ahead and pull ourselves back over to a 101 because we're now starting to throw around terms that we'll get to in later classes.
Someone did ask, though, is it good practice to set your objects to null when you're done with them, or is that overkill? If you write if you do it right, you shouldn't ever have to explicitly set an object or a variable pointing to an object to null. Your object should just they should just stop being referenced. Because generally you'll have a bunch of objects added to a list, and then you might want to remove it from the list when you no longer want to use it. So generally speaking, you don't have to explicitly set things to null, except for in cases where you really know what you're doing and you're performing a very specific optimization.
Okay, so let's pull back around to just the basic discussion of OOP.
Okay, so somebody asked, why would I create a class that just has a string in it? And why can't we just do this? String pony1 name equals blah. String pony2 name equals whoa. Well, what if we wanted to store the colors of each one of these individual ponies? So we could say string pony1 color, or what if we wanted to store what other attribute can I use in this case? Cars were easier.
Height in hands?
Yes, height. Whatever, it's irrelevant. So you see what's going on right now is we want to store a variety of different information about these individual objects, but by limiting ourselves to just using straight up variables, there's no. Well, okay. So, for example,
well,
let's say
Nelson has that. Nelson, look at that. You have that all neatly grouped together right now, but that doesn't mean anything in the context of main as you start coding further on. So it's all, it's just all a jumbled mess. That could be put in any order.
There's no value at all with this code. Furthermore, what if we wanted to make a method called display pony? What would we need to put into the parameter list? Anybody? Any guesses? Because we want to display all the different attributes. What kind of parameters would we need to pass into a method that displays them to the console? Yeah, we would have to bring all of them. We would have to say string name, string height, string color. Then we could say, Console.WriteLine, name, height, color, name, height, color. And then to actually get this to display right, well, we're going to have to do pony1 name, pony1 color, or sorry, I shouldn't have done color, I should have done height. So let's erase that and fix that bug right there that I just introduced. Color. And then what if we want to display the second one? Well, now we have to do 2. Okay. Can anybody guess from a level of 0 to 10 how much fun it'll be if we had continued to write the program like this and we ended up adding an additional attribute to our ponies?
Nice one, Flash. Over 9,000!
Asymptotic to very.
The what?
Mr. Maths there.
Now leave all of that in place and let's, because our numbers are all over the board, let's go to, let's now start adding this into Pony to make the Pony class more flexible.
Yeah. Let's go ahead and represent all of this logic that you see right here in a much cleaner way. I'm going to add 2 more fields, and then we're going to do something crazy. Check this out. What's this? It's a method. I just put a method into a class, and this represents the behavior of the class and what it can do. Now, the cool thing about this method is this method is going to be carried around with every instance of that class. And it's going to have access to the values stored in every one of the fields of this particular class. Meaning, I could simply do Console.WriteLine name So what I've effectively done, think about it this way. This is a cool way to think about it, and a way that people should really concentrate about OOP when they're just starting out, is what I've done is I've factored out code that was repetitious into a class. And what I've done is I identified first of all, identified what makes each one of these objects unique. And you see the way I'm handling things. I have pony1 name, pony2 name, and so on. So name is one of them, then pony1 height, pony1 color, and color and height are other ones. So we've established the data model of each one of the objects we want to work with as 3 strings of name, height, and color. Then we established what behavior that we're doing over and over and over again to these different variables. And we've identified a method called display, which we can factor out into this class. So now this class contains everything required to set 3 variables on one object and display them. Can we loop through all instances of Pony? Good question. We'll definitely be looking at ways to do that very shortly here.
So why don't you go ahead and push, starting at line 24, push that down, and let's go ahead and make our 3 ponies using the pony class.
Brian will definitely be talking about static during this class. Okay. So does everybody recognize why this code is brittle, annoying to work with, and difficult to read?
Because you wrote it that way. You're lucky. I was just going to say because you wrote it.
Now, if we look right here, the difference is the approach that we took. We took an object-oriented approach to this problem in this case, and we've significantly cleaned up the code. And
the data is truly encapsulated with each instance of the pony class.
Yep. So every single object is going to carry around all of its state. And that state is specific to that object. There's no shared state. Well, there is with the static keyword, blah, 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 blah. So in this case, we have these two instance classes that, again, their state is carried around it with them. It's encapsulated within the class itself. In addition, we have functionality on the class itself that we can reuse in a variety of different circumstances.
Now, Leonard had a question over in BuzzNet, if you saw it. He asked about, what if you have 150 attributes?
Well, then I would probably end up with, well, it depends. The answer to that question really depends. First of all, I would not have a class that has that many attributes in it, ever. And the reason is we'll get into fields and stuff soon, but generally speaking, classes should be relatively small and very specific to a particular purpose. If you have 150 attributes, the chances are you have one of two things happening. Either one, you're shoving a bunch of attributes into classes that should really be broken apart, or two, you should really come up with a better abstraction to contain those attributes. So instead of having those attributes being fields on your class, you could use a list of strings to represent your attributes, for example. That would be more appropriate once you start talking about a bunch of different attributes.
Like a property bag?
Yeah.
Which we'll be talking about properties shortly.
Okay, so are there any limitations to doing this way versus the old? No. Well, I want to say no, there aren't, because this is the way you should be doing things. But here's the thing, though. Everybody here who's new to programming and has not used object-oriented programming before, or even people who have used object orientation before, they're going to run into situations where the way that they would have previously done things seems easier than doing things with classes. They'll be used to things like global state, or used to things like implicit relationships between code halfway down the code file that you never abstracted into a class, or they'll be used to doing things in a certain way that it'll make it seem like this new object-oriented approach is so limiting. I can't use, or I shouldn't use globals, or I should really think about how my code should work instead of just tossing a bunch of stuff at the screen. But it is without question better to do it this way, even if it feels limiting at first, because the whole point is that eventually it will not be seemingly as limiting.
It's limiting in the way that a choice of color palette is limiting if you're painting a picture. They're good limits.
Well, hey, Nelson, I have another example that you could code up real quick that I think, I was just sitting here kind of thinking of this whole problem from a beginner's perspective. And with the questions being, why can't I just make a bunch of variables to represent this? Here's an idea for you. Why don't you, instead of having a pony class, what if you, let me go ahead and get all the way through this before you start. What if you had a class called student, and then what if we had we could do a couple course classes, or just a course class, and students could have a list of courses. And if you put something very simple together like that, we can make a couple students, we can put one student in this course or one student in that course, and we could still keep that code pretty small here on the screen. But then, after doing something like that, then think about how would you go about doing that with just a whole bunch of local variables?
Alrighty.
I'm just trying to come up with other practical examples that, again, because I'm remembering all of the feedback that we got from Monday night's class.
I'm going to do something a little bit crazy here.
Oh, you put partial, and I was like, what the?
Actually, I'm going to do two things crazy here. I know I might be getting ahead of myself here, but we'll definitely be going over everything that I'm typing here in this specific class.
Public course that you've just made is that is coarse as in coarse grain, fine grain.
Instead
No,
of,
it's not. I'm talking rubbish.
instead of putting a constructor in, they are familiar with initialization, and you can just use field initialization and pull the constructor back out for now.
All right.
Just to keep it simple.
It must be getting late. I've lost the ability to spell. My powers are waning.
What am I doing?
I don't know. And call student 1 like Nelson and student 2 like Gavin. Just there you go.
Because that's the better way to do it, Harrison. That's infinitely preferable.
To what?
I got a lol out of Lyric for that. Hare said, why is Nelson using VB style casing with the underscore?
Oh, VB style?
Hey, I'm only quoting him.
What is VB style? I don't even know if VB has a style.
Let's stay focused.
And if it does, it's probably awful. We'll be talking about my private variable here shortly.
That just sounded wrong. And that's not how you spell Gavin.
Nelson, just tell him it's the way you spell Gavin.
Gavin.
When did we learn init? Not in Monday class. Huh? Barry, not following you.
Okay.
Init isn't a built-in method.
No, it's not. It's just a method. Period. It's just, he could have called it whatever he wanted to. But go ahead and change it back to, change it to initialize, just so that it's Initialize. I'll help you out.
That's why he called it init. Init.
I know, that's... All right, now, Nelson, do me one more favor. What I want you to do is split the screen and then put program on both sides and show the lower half of program on the right, the upper on the left, and let everybody type this out.
Maybe giving me a chance to go step outside too.
I know. Yeah, we're going to take a break. Give everybody a chance to... Yeah, perfect. Oh, come on, Captain. No whining. That's not bad. So do me a favor, Nelson. Go ahead and reset the ready check. Again, guys, we'd like for you to participate. If possible, that would be fantastic. Just hit the participate button inside of BuzzNet.
And my name doesn't have an E in it.
Oh, internal void. Where did that come from?
Okay. So what I want for you guys to do is go ahead and type this out. NATO, why are you not following along? Toastage. And don't answer that, Toastage. NATO's toe hurts. Aw. No, it's not all under class program. Look on line 45 on the left. As a matter of fact, Nelson, scroll up just a little bit to put 43 at the bottom of the left. There you go.
And correct the spelling on my name.
I don't know how to... Do you have an I in there? Or is it an E?
Gavin. Tar.
Okay, so what I want for everyone to do is to type this out. Once you're done, make sure you set your ready check so you're ready, so all is done. And then go ahead and take a break. And then we'll walk through the entire thing afterwards. But this is a much better practical example. It's still a very, very simple one. So I'm going to go ahead and pause the video as well, just so that we're not recording dead time. Okay, and we're back. So now let's take this practical example and let's break it down. And let's show how these objects are helping us with their encapsulation and the behavior that they have built in as well.
Well, yeah, I mean, what we've done is we've taken a lot of code that would normally be strewn across the main program, and maybe, if you're lucky, a few methods on the program class itself, and we've encapsulated them into these objects. And these objects are nice because they really give a feel for what their purpose is. They really give you a nice feel for what kind of data that they contain, what behavior that they expose. And we can take that data that they contain and the behavior that they can expose, and we can use it over and over and over again by instantiating the class into a bunch of different types or a bunch of different objects. So as you see here, we have 3 instances of the student class, meaning that we have 3 objects that follow the blueprints of this class. And the blueprints of this class specifies that every object instantiated from it will have a string field called name and a void method called display. Now, we wanted to contain a list of students, but more importantly, we wanted to contain a multiple list of students, because we wanted the concept of multiple courses. Now, we could have just done a list of students inside of our instead of our main method, we could have had, well, the course one will look like this: list of student or course one students equals new list of students, string course one name equals intro to C#. We could have done that, but that will lead us down the exact same path that we saw earlier with the ponies. So in this case, or what we did to actually fix this problem by making it, by reducing the amount of maintenance that we would have to do as the concept of a course grew in our program, we turned it into a class. We abstracted or factored out the different aspects that constitute a course, and we placed it into a class. And this course class, which sounds kind of confusing because the whole class, course, English, blah. But you know what I'm saying. This course class is a representation of two pieces of data and 1, 2, 3 pieces of behavior. So the two pieces of data that we contain with every single object we instantiate from the course class is a list of students, in this case called _students, and a string name. The 3 pieces of behavior that we have are the initialization, the adding of a student, and the displaying of all the students that are currently in the list. Now here's the important, or well, we haven't talked about public and private yet, so I'll get into that in a moment. But so we have initialization, add student, display. So when we go down to the example of the code that uses it, if you read this sort of thing out loud, it starts to really sound like English, where we say, you know, student Nelson equals new student, Nelson.name equals Nelson. It just looks better and sounds better. And although some people might not be familiar with looking at code like this, I guarantee you that as you continue to use object-oriented practices, this code will speak to you a lot more than the similar procedural representation of the same logic. So we continue with creating students. We create 3 students, and we assign them all names. So now that we've gotten all of our students, we go ahead and we instantiate our courses. So we instantiate 2 courses. Now the first thing we do with both these courses is we tell them to initialize, and this is very important. The reason this is important is because each one of these courses has this students field, which is a list of students. Now if we do not instantiate a list of students, this variable will be null. And because it'll be null, we'll get a null reference exception when we try to access the data from within it. Because list of student is a class, it must be instantiated. So we were forced to instantiate it at some point. So what I did was I created this nice little method called Initialize that you have to invoke immediately after instantiating a course. Well, you don't have to, but if you don't, you'll run into issues.
Now you can obviously use field initializers as well.
Yes, but I don't like field initializers.
Why? It's for sure it'll be initialized.
It has to do with the fact that constructors are called from the basemost class up to the most derived class, but field initializers are invoked from the least derived class to the most, or from the most derived class to the least derived
opposite
class.
direction.
Yeah, meaning if you use a combination of virtual members and inheritance and field initializers, your code will blow up.
Yeah, you could get yourself in an interesting position.
Yeah.
Don't worry about it, Insomniac.
Yeah, actually, I was just thinking that sounds like a conversation I need to have with Nelson.
Yeah, so here's the rest of the code, and again, I block someone up of the house, which I apparently do quite often.
No, son.
Hey.
You're getting faster. That's impressive. Okay, continue.
Okay, so we instantiate all of our students, and we assign their properties. We instantiate 2 courses, and immediately after instantiation, we invoke the initialize method on each so that our list gets properly initialized. Following that, we set the properties on them. In this case, there's a single property. Well, I'm not referring to properties in the sense of the C# language. I'm referring to properties as an attribute or a piece of data associated with an object. So if I accidentally let the word property slip, even though we're not using properties right now, what I'm referring to is the English definition of the word property. We are a setting, an attribute of this specific object, which will not be shared with any other instances of the same object. Meaning, like what you see right here, two examples of this where we have multiple copies of these classes running simultaneously that have no direct relationship to each other. But here's where things get interesting. Because they have no relationship to each other implicitly does not mean that they can never have a relationship with each other. In fact, object-oriented programming is all about the concept of creating objects and defining the relationships between each object so that they can work together in a very clean way. So what we do here on line 66 is we invoke the addStudent method on the intro to CS object, and we pass in another object, a Nelson object, well, a student object with, in this case, the identifier is Nelson. When this code executes, this method gets invoked, but it's important to know that the student's field of this object is specific to the instance of the object we are invoking the method on. Meaning, when we say intro to CS.addStudent, this is going to add it to a different list than the intro to CPP.addStudent. Because these are different object instances, the fields are different objects themselves, meaning that the addStudent method will perform operations on the student's field that is owned by any of the objects that the addStudent method is being invoked on.
So really, neither of the addStudent methods knows about the other, if you see what I mean.
They're completely discrete methods.
Again, those classes are just blueprints.
I didn't mean...
They're just templates. And so we instantiate, we create two objects, two different courses from our class template, our course template. And then each of the fields inside, those are instanced members, which means they're completely separate from one another. Each of those objects, the Intro to CS course and the Intro to CPP course, they each have their own data, their own copy of that data, basically.
Yep. Somebody did ask, so do these run at the exact same time? And the answer is no. With object-oriented programming, execution is still linear. So what I did was I set a breakpoint here on line 49, and I opened up the debugger. So now I'm running the debugger now. And I'm going to watch as execution continues to run just like it did before, linearly. So on line 59, if I was to hit F11, you'll see that we jump into the Initialize method of the course class. And then on line 63, if I were to hit F11, we jump into the Initialize method here. If I jump into the addStudent method here, you'll see that we continuously add students to this object, and then same here. Now, if I were to inspect any of these objects and look at the data that they have inside of them, remember, I'm in the debugger. The program is running, which you can't see right here because I full screened it. Let me go ahead and the program is running. So here's the program. It's just, I thought I turned off Arrow Shake. No, I turned off the desktop. I really need to figure out how to turn off Arrow Shake. I hate it so much. So imagine I'm shaking this window right now. This is the running program that has currently been paused by the debugger, and we're about to execute line 72. But if I go ahead and mouse over the individual objects, you'll see that what data they contain. For example, when I mouse over an Intro to CPP and expand this, you'll see it contains one student and has a name of Intro to C++. If I hover over the Intro to CS object and expand it, you'll see that its students variable contains 3 students, and that its name variable is set to Intro to C#.
Go ahead and expand the students.
Yeah, each one of these students is going to be the individual student objects that was added to them.
Now, Nelson, you do have a pin now, so if you want to give this a try, because we did have a request for it over in BuzzNet, about could you just draw this out with some very basic blocks? So why don't you do that?
Alrighty.
Oh, one thing I was going to mention, because I said it the other day, which is if you just outline the
Brian, that's a good question. We'll get to that.
Yep, he got the new Wacom tablet.
Hold on, the button's stuck. There we go. Okay, so that's definitely not the brush I want. All right. So what aspect do you think I should start drawing from? The object or the class aspect? Whoa.
Whoa.
What? Hold on, did I? This? No. Here, I'll turn on touch. I think I might have rotated the canvas.
Is this a magic trick?
Oh, there we go. Now I'll turn off touch. There we go. Okay, so that was the magic trick of the day. So people were talking about kind of drawing this out. So what we have is and please excuse my handwriting and or drawing.
It's just as incredible as mine, so you guys should be used to it already.
It's probably worse, which is why I'm really hoping that
it's
a drawing course at some point. Also, that's not the color I want. There we go. Okay, so let's go ahead and click and clack. Yes, I got the DOS keyboard, or Wacom tablet.
DOS pen. Okay.
Okay, so what we have here are two classes. We have our student class and drop that down a little bit. Cheat. We have our student class and we have our course class. And sorry, this
is good practice for Nelson, guys.
It really is. I haven't.
It's really, really hard. It is
because I'm spending so much.
Writing with a tablet is so hard.
Anyway, so we have our course class and our student class. Now, our student class is going to have a single property, and that property is going to be name. It also has a single behavior. So I'm going to separate the behavior and the properties with a line. And again, I'm accidentally saying the word property when I should be saying the word attribute. So it has a single attribute and a single operation. So the attribute it has is the name, and the operation it has is display.
The behavior it has is display.
The course class is a little bit more complicated. We have our students, and we have our students, and we have the name. Those are our two pieces of data that our course contains. Now, underneath that, though, it has a little bit of more functionality, where it's going to have the concept of adding a student, and displaying itself. So now that we have these two classes, what we can do is we can they actually do have a nice little relationship. But here's the important thing that really you need to really drill into your head. This is compile time, or this is the code that you write that really only makes sense to, the compiler. Although this isn't C++, so there still is runtime type information, but still, the important thing to know is that these are not objects. These are classes. These are templates. So I'm going to say right up here, these are compile time concepts. So these two boxes represent the individual classes, and they relate to each other at a compile time level. So for example, students is actually an aggregation of the student type, meaning this variable right here contains multiple ones of these students. In addition, the add student, let's make that actually say add student. The add student method also takes in a student to add to the student's variable. So, okay, so this is the compile time concept. But when we actually go into runtime, we have a variety of objects that are going to be instantiated from one of these two classes. Meaning I could have, a JSON student, and I could have a Nelson student. And then I can have a Gavin student. These are all students. And I don't know if I'm going to be able to write sideways, so I'm just going to...
It's getting better by the second.
Okay, so we have a variety of students at runtime, and all of these are of this type, meaning that they contain the behavior and the data that this student object contains. But most importantly, these objects can be used with other objects and other methods that expect objects of this particular type of student. So we'll also have a variety of courses. So we'll have, like, for example, the intro to C++, and then the intro.
Actually, can you do those side by side, and let me get you to have those boxes a little bit bigger to represent the object, so that you can have a box inside of it for the list of students for your two courses.
Side by side.
Yeah.
Oh, okay.
Just to kind of help drill the concept in on the encapsulation.
How much am I failing at this, by the way?
You're doing fine, and I agree with Ryan. Practice makes perfect.
Oh, thank God for the shift key.
Oh, you're already doing better than Jason then.
Oh yeah. I even
You
failed
found
at
the shift key.
I even failed at the shift key.
Well, I imagine it's feet away from.
Okay. So now we have these two instances of these objects, and these are courses. So each one of these objects is of this type. They follow that template, meaning that each one of these objects has, at runtime, a students field, a name field, an add student method, and a display method that is localized to just those two objects. Okay, so what we can do here is we can actually compose our students into the course by saying that we want to add JSON, for example, into the Intro to C++ course. So what we can do is we can actually add him into this course by invoking the add student method. And then we could, for example, add Nelson into the C++ course by invoking, again, the add student method. And by invoking this method, which is up here, which is available on any instance of the course class, we are effectively adding this data into the local students collection. So if I wanted to represent that graphically, I could write, students. This is the state. Students is the state of each one of these. Oh, come on.
You can do it, Nelly.
I'm working on it. Students is the list that each one of these classes contains. And most importantly, there are two of them, because we have two instances of awful boxes.
Underscore.
I know there's an underscore. Oh, go away. Oh, great. Oh, I think it's my rotating thing. Go away. There you go. Come on, please come back. Oh, come on. This is like a sick joke. Right with an angle. Okay, rotate. And I'm rotating it, and it's not going anywhere. It's opening up the eyedropper tool, which isn't what I want. Control Z. Let's see if that is in my history even. Wait a sec, Photoshop does not focus. Ah.
Yeah. Okay. What are you doing?
I don't know. Oh, it's just really, really, really slow. Hold on. I got it. There we go.
Hooray!
There.
There we went.
There. Now I'm taking this off the rotate function. Okay. So, I'm sure it's just a bug in the beta or something. I don't know. So getting rid of this box and drawing a new one. The point here is that there is a student's collection in each one of these objects.
Their own collection.
This is just...
Do you have your brush selected?
Why did it get down to pin light? And why is my opacity set to 71?
You hit every hotkey imaginable. Again, just remember what Ryan says, practice makes perfect.
Yeah, I think elevating nailed it. Hit D.
Okay, you're white. There you go.
Okay. Okay, so now let's draw another box. So this is how you draw a box in Photoshop and how you fight with Photoshop. Okay, so there are two students' collections. This is the important thing. This is an object, and this is an object. They're both completely discrete, unrelated objects. The way that they're related, and maybe I can show that a little bit better here by, or demonstrate that a little bit better by simply doing this. The way that these two objects are related is they're instantiated from the same class, and the class that they're instantiated from gives them a certain amount of behavior and data. And the data I'm representing here with these boxes, and the behavior I'm representing here with the arrows. So by invoking the addStudent method, which is this method right here, and I guess that because they're the same name, the line might not be as relevant. Because I'm invoking the addStudent method on this object in particular, this student gets filled. So as a result, Jason and Nelson both get added to this student's collection. The other student's collection is empty because remember, this is at runtime, and at runtime classes don't mean as much because what we have instead are objects. And by invoking the addStudent method on this object, we are adding these two items to it. So if we were to invoke the display method, for example, which you see defined up here, we would get Jason and Nelson. If we were to invoke the display method on this object, instead we would get nothing because this has an empty collection inside of it. But if I wanted to go ahead and get a student into this object, I could use the addStudent method. So I could essentially send this object into this collection by, again, invoking addStudent. And as a result, Gavin is now in the C# course.
Yay.
So did I end up just confusing people even more, or is everybody good?
I mean, if you're just able to look at this and take the top part of that screen, the compile time concepts, we have two blueprints. Nothing exists except the blueprints. And from those blueprints, we're able to construct multiple instances, as many as we need, actually, as much memory as we have in the computer. And Nelson has created 3 instances of the student class. So we now have 3 objects. And the state has been set. I mean, you keep hearing Nelson say the word setting state. And that is setting the attributes available inside of the student instance. Okay, each instance of student. So by setting name to Jason, we've given that one state. And by setting the next object, setting that name to Nelson, it has its own state. And its state is different than the Jason object or the Jason student object. And same for Gavin. So we've created 3 different objects. We could create as many as we want. We could easily write a little UI that would let somebody come in and say, add new student. And you could see with add new student, that's obviously going to instantiate a new student class. And then you could fill in the information, and by filling in that information, you're setting state for that object. Remember, it's no longer a class, it's now been instantiated. We now have an actual object. And then Nelson turned around and he created 2 instantiations of the course class. So we have 2 actual course objects now. And again, he set state by setting one as intro to C++ and the other one as intro to C#. And then we called upon behavior that was available in each of these objects, each of these course objects, that allowed us to add students, student objects, to the list of students that would be taking that course. And so basically what he's got going on here is just a drawing kind of demonstrating how the big thing as a complete beginner to take away from this is he's just trying to demonstrate that we have 2 classes that are nothing more than templates or blueprints for these 2 types of real-world type objects. And then the bottom, the runtime section of his whiteboard right here, he's showing where we've actually created some objects, some instantiations of those classes, and we're putting it all into work. So hopefully that helps kind of sum things up just a little bit. And I know for those of you guys that are sitting back right now kind of being patient with us, I do appreciate it. With Nelson's, I think this is great that Nelson is getting the practice in on the whiteboard right now, because there have definitely been some of Nelson's much more advanced courses that we've done that would have been fantastic to have had some whiteboard demonstrations to help kind of, you know, make a little clearer what it was that he was setting up and doing.
Okay, somebody did ask, the student's state's being changed, but how does that happen? The student's state isn't actually being changed. The course's state is being changed. See, by these 2 courses are 2 individual objects, and they own their own states, so they own their own collection of students. When you invoke the add student method, you are changing the state of the courses by appending on one of these students to that list. Okay, so are there any questions about
what we've looked at here? We can go ahead and jump back over to code now if you want, Nelson. Good job, by the way. You really did do a good job.
I want my drawing course now. Okay, so now that we have seen that in a graphical representation, albeit rather shakily, this is it in code, where you see that we're creating 3 of these student objects, and we are assigning their name to something in this case. Now, that wasn't necessarily represented on the board. I kind of implied that there, but in code, in order to set state on an object, you're going to have to set a field on that object, and that's what we're doing here. We're setting the name field on each one of these objects to something discrete to sort of demonstrate that each one of these 3 objects is a discrete entity within the system. And most importantly, these are objects. When I say object, I am referring to runtime. Objects are a runtime concept. Classes are a compile time concept. Now, we initialize 2 other objects here, the 2 courses, one named Intro to CS and the other one named Intro to CPP. We initialize them, and then we establish their name. But this is where the interesting stuff comes in. This is where those lines and that box come into play with the add student method. By saying intro to CS dot add student and passing in a variable, we are invoking this method. And when this method gets invoked, the student's collection is getting updated with a new object that we specified as a parameter into this method. So by specifying that this method has a student parameter, when we fill it up with an argument at runtime, that argument or that variable then gets set to the student we want to add to the class, and then the students.add, this line right here, line 31, gets executed, which adds that student to the collection. Now remember, this collection is localized to each one of the individual courses. As you see right here, each one of these courses has their own students collection, and each one of the students collection is completely discrete from each other. So by telling the intro.tcs to add a student of Nelson, we are changing the state of this one object and not of the other object, which is the intro to CPP.
So, are there any questions?
Someone did bring in a good question a while ago. He asked, can I side by side with all the code again? Sure. Okay, so somebody asked a good question. He said, if you changed the student object JSON's name to BuzzBJ after it has been added to both courses, will that change take effect in the copies of the JSON object in each of the courses?
Ooh, that's a great question.
Yeah. The answer to that is, well, what copies?
Exactly. That's why it's such a great question.
You'll notice that I add the Nelson object to both one of these courses. If I were to edit the state of the Nelson object before displaying either of these courses, you'll notice that this actually does change the behavior of these method invocations. As you see, my name is now Lakay instead of Nelson. The reason that happens is because when we say intro to cs.add student Nelson, we are passing in a reference to an object.
So let's jump back over to the whiteboard real quick. I think you can kind of demonstrate that. It might look a little rougher, but this might help. So go ahead and erase the JSON and Nelson on the C++ side.
You mean everything down here?
In
the runtime?
In the runtime, in the intro to C++, inside the box, just the word JSON and Nelson. No, not there. Oh. In the C++ box. In the list of students.
Right in the middle of the screen.
There you go. I was just trying to talk as simple as I could for you. Now just put 2 dots in there to represent us, and then draw arrows over to our. So like darken it in. Darken it in. Come on, be a man. There you go. Look at that, and another one. Now from those 2 dots, just draw a line over to Jason and one over to Nelson.
Actually going to go ahead and just remove these for now.
See, Thursday night's the smaller class, but man, you guys get the extra special treatment. I just had Nelson do dots instead of addresses because I didn't want things to get even more confusing. But we are, and make those lines, yeah, that's good enough. So we're referencing these students. So if there are any changes whatsoever to these student objects, they're the real objects that are in the students class. That's in the list of students for the Intro to C++ class and in the list of C# ones. So by changing Nelson, as he demonstrated a second ago, by changing that name from Nelson to Lakay, displaying out the Intro to C++ class would show the change. And if he was in the C# class in this drawing here, it would also show the change because we're referencing the real student object that contains the state Nelson in both of these different course objects.
Can I throw something up real fast?
Yeah.
It might confuse people, although it might make a lot more sense to people.
Okay.
I'm just taking a chance here. Shut up. Oh, where'd my stuff go?
Did you just tell you told it to shut up. So it left. It shut up.
Oh, did I put in 30,000?
Yeah, because you did 1,000 inches, not 1,000%.
Oh. Let's go ahead and undo that.
That's pretty funny, actually.
Derp.
There we go. What? I did width. Oh,
Have you considered the benefits to be found in looking at the screen?
You don't. I'm just letting you know, Nelson. You don't need drawing classes. You need Photoshop basic classes. We can hook you up with that, you know.
Yes. No. I knew it's just the whole pressure of doing this
We're,
live.
we're, we're with all friends.
Normally,
We're with friends. Just relax, man. Relax.
okay. So we have the main method right here. And then we have a line of code that says student Nelson. I'm just going to do that right now. And then we might have a variety of lines right here. It doesn't matter what they are. And then eventually we'll have a Nelson equals new student. And then we might have some more lines right here. And then we might have course 1 dot add student Nelson. Okay, is everybody good with that method, at least what's going on so far? Because there's a bit happening behind the scenes that's important to realize when working with classes. And actually, I do kind of really want to explain this here because some of the questions we had coming in from the Monday class dealt with the fact that we didn't explain this at that level. And I'm not going to go in depth into what I'm explaining, but just enough so that people can get a good conceptual idea about what's going on so that they can at least start doing things useful with classes. Now, when this happens, when this line happens, nothing changes at all. This is not executable code. Saying student Nelson semi is not executable code. All this says is that main should have enough memory inside that function when the program starts so that it can contain a reference to something down the line. Now, when this line executes, this is where things start happening. And it's because of the new operator. The new operator will actually jump all the way out into memory, a special part of memory called the heap. And request that the computer then allocates enough memory to contain the data that the student class needs in order to exist. So when this line executes, it goes out, it jumps all the way into the heap, and what happens is well, I get instantiated. Now the heap is very big, but I get a special little location on the heap that contains my data. It contains all of the data that I need to be represented per my class. So this data is in the heap. It is not owned by main. Now, some data is owned by main. Functions can own data. But in this case, by invoking the new operator, we have then requested that the operating system provides us a special place in memory that we can hold our object. So what we get back here is a reference. So if I were to circle this, the new operator goes ahead and asks the operating system for memory, which then gets allocated. And then a reference to that memory then gets set to this variable. This variable contains a reference to this memory. This memory exists inside of our main RAM, and this variable contains a reference to it. Now, when I invoke course1.addStudent Nelson, what's happening is the reference that this variable contains at this point gets copied into the addStudent method. So when the addStudent method gets invoked, so here's main, I'll delineate that, and then I'll show you the addStudent method.
This is the bit where I start to come unstuck. Because you say it gets copied in.
The pointer to it, the address, not the actual data.
Okay, so here is the single line of code inside of the add student method. And the single line of code simply says students.add student. Now, what is this? If this method was invoked as you saw up here, what is that thing that I just boxed?
Use BuzzNet. Try to answer. It's good for you.
All right. This variable, and some people answered correctly, is going to be a number. Let's call that number XXXXX. This reference, this location in memory, is this number right here, and memory will start at 0 and end at the and end the addressing at max address, just like an array. This data, this number, gets sent into the add student method, and this number represents a location in memory that we created previously, meaning that both the Nelson variable inside of main and the add student method invoked as you see right here will be pointing to the exact same object, the exact same memory, the exact same fields, because we use this magical new operator in the context of a class. This is how all classes are handled in C#. There's another kind of type called structure, which isn't handled like this, but we're not getting into structures. We're just talking about classes. And all classes in C# are handled like this. When this method is invoked, we are getting a PO box number, you could say, for this data. We're not getting the whole data. We're not getting a copy of the data. We're just getting a location in memory that we can then use to access the data.
We're going to get the constructors here in just a few minutes.
Yep. Does an object basically to a memory location then? Well, actually, for classes, yes. All objects created from classes are going to be equivalent to simply a location in memory, period. That being said, types like integer and double and float and enumerations behave a little bit differently, but again, we're not getting into that. We're just talking about classes. And with classes, every single time you have a variable that points to a class that is a reference, and that class data is going to be made available to us on the heap, and our program is simply going to be given a number back that it can use to reference back to that data, meaning that when we pass it around to other methods, we don't get a copy of this data, we get the actual data itself. But the reason I wanted to split that apart here, the reason I wanted to actually introduce the concept of the heap is because I wanted to point out that main doesn't even own this data. Main and add student do not own Nelson. Nelson is owned by the heap, which is something outside of the program, or outside of our executable code, I guess you could say. Yes, the new operator is what's responsible for instantiating a type. So this is the process that instantiation takes on every single type that's a class. Every single class that we use the new operator with will result in this behavior. This behavior is valid for all classes. Okay, are there any questions about what is going on here?
Because this will be a good point here in just a second. We'll take a break, and then we'll pick back up with introducing constructors, I think. Does that sound good to you, Nelson?
Yeah.
All right, let's go ahead and take a break, and this time everybody gets an opportunity to stretch their legs or go grab something to drink or uncross their eyes, Wick. And 10 minutes, and we'll meet back. So I'm going to go ahead and pause recording now. Resuming video. Let's go.
Okay, so Brian, I know you had an innocent question that kind of turned into this huge discussion about the heap. Did I answer your question, and does anybody else have any further questions about the concept of instantiation resulting in some space on the heap being reserved synergy for us? There we go. The space on the heap getting reserved for us by invoking the new keyword, and then passing that memory around by simply passing a reference to that memory around. Go away. How do you take that memory back? Good question. This memory will continue to be in existence or continue to be reserved until the garbage collector decides that you're no longer using it, which is one of the nice things about C# over C++ or C, because in C and C++ you have to manage that memory yourself. With C#, the garbage collector knows when you no longer use this memory, and it knows when it can go and remove it. And it's very efficient about this process.
Nelson?
Alrighty.
Okay.
So it looks like, well, no, I do that. I give a pause for any last questions that come in, but it looks like we're probably good.
Yeah, I think so.
So let's go ahead and talk a little bit about constructors. Now, in many object-oriented programming languages, you have the concept of not finding the right window to open. You have the concept of what is called a constructor. And a constructor is a method, a special method that gets invoked whenever your object gets instantiated. Now, by now, most of you are going to be familiar with this syntax. And you notice that on line 66 or 68, for example, we use that right here. We use that to invoke a method. Opening up a parenthesis, passing in some arguments, and then closing the parenthesis. And you'll notice that we do something very similar when dealing with object instantiation. What's actually going on is a special method gets invoked whenever an object gets instantiated, and that method is called the constructor. Now, I want to introduce a very interesting problem that we have with this code. You'll notice that we have to invoke the initialize. You'll notice that we have to really. You'll notice that we have to invoke the initialize. Are you messing with me, Jason?
No, I'm not touching anything. It's your synergy freaking out, I guess.
Well, no, synergy. No, let's go ahead and kill synergy. Oh, God.
Is your pen giving you grief?
No, it's nowhere near anything metal.
Like on the tablet? How about, is your touch tablet activated? Are you touching your
No,
tablet?
I turned that off. Okay, I just forced my tablet off.
Okay.
There we go. Okay, so you'll notice that we invoke this initialize method every time that we invoke or instantiate a course. Now, if you'll remember what the initialize method does, hey, look, here's that new thing right here. This new operator behaves actually exactly similarly to how the new operator works with our other classes, because list is a class. So you'll notice that By default, this students variable is pointing to nothing. It's an empty reference. It's a null reference. But we need to fill it with data in order to use it. So we need to instantiate a list, meaning we need to ask the computer to give us the memory that will contain a list, and we need to assign that reference to our students variable. So for this example, remember, I'm going to go ahead and split the window again. For this example, keep in mind what the initialize method does. Now, on line 59, I'm going to remove the invocation of the initialize method on our intro to CS. I'm just going to comment it out. If I were to run this program, what happens? Notice that I'm no longer invoking the initialize method on our course object. Can anybody guess? So I get some null exceptions, some errors, some null reference exceptions. That's all good. Can anyone guess the line number that the null reference exception is going to be invoked or is going to be thrown on? It's on the screen right now. Which line number is going to? So we got some 20s and some 31s. I've got some 24s, some 31s, some 29s. ITF, I know you know the answer to this question, so you don't really, or you better know the answer to this question.
And stop trying to blame other
sorry.
people. Wick was able to throw an answer out there.
Yeah. Okay, so I'm going to go ahead and hit F5. We indeed get a null reference exception, but we get it on line 31. The reason we get it on line 31 is this is the first time in this object that we try to use the student's field. And you'll notice if I move my mouse over it, it says null, because this is a null reference. This is referencing nothing. So as a result, when we invoke the add student method from this line right here, line 66, it goes into the add student method and it tries to add a student to the student's collection. But because the student's collection is null, we get a null reference exception. This is obviously very problematic. Very problematic. The reason this is problematic is we just introduced the possibility of a bug in the instances where a person didn't manually invoke a special method that they should only invoke once, because if they invoked it multiple times, you would have got funky behavior. And it's not very good. That's where that special method comes into play. The special method that every object or every class has, called the constructor. Now, the C# compiler will generate an empty default constructor for every class that does not define a constructor itself. And you can notice that by when you open up the curlies right here, you'll notice something that looks vaguely familiar to a method invocation. You see a tooltip pop up saying course.course empty parenthesis. So what is this? This is the default constructor. We are invoking a method. The method is just an invisible method that the C# compiler generates for us when we don't create our own constructors. So let's go ahead and we're going to turn initialize into a constructor. So I'm going to remove these two lines that invoke initialize, and I'm going to delete the initialize method, and I'm going to rewrite it as a constructor. Now, a constructor takes a very special form. You start with your access modifiers. Remember, although we haven't talked about access modifiers just yet, all members on a class will start off with their access modifiers and potentially any other modifier that you might want to add to that member. Now, after you specify the modifiers that you want to add to your constructor, to actually define your constructor, you simply type in the name of the class that you're currently working in. After this, you continue to define a method just like you would do before. Meaning that we are defining a method that takes in no parameters and that currently has an empty body. But we can fill in that body with whatever executable code that we see fit. In this case, we know that we want the student's list to be instantiated to something. We don't want to run into an instance where we get a null reference exception because null reference exceptions are bad. So what I'm going to do here is I'm going to say students equals new list of student. Now what I've effectively done is I've created a line of code that's going to be executed every single time a course is instantiated. So there's no way to instantiate a course without the course having an opportunity to run its own housekeeping code to keep its own state valid. And we're making the state valid by assigning our student's field to a properly instantiated object. So now if I were to run this program, we get the same behavior that we had before, which is awesome. And we do not need to invoke the initialize method manually, and it is currently impossible to create a course object without having students instantiated to something. Now, what's important here is because we defined our own constructor, the default constructor no longer exists. The default constructor is only added when there is no constructor specified on your type. So you'll notice a few things about constructors is they have no return type, and that's very important. Some people like to think of the return type of a constructor to be the object itself, which isn't a bad way of thinking about it, I guess. But the point here is that you don't specify a return type. If I were to specify a return type, I'll get a nice little error because I would get member names cannot be the same as their enclosing type. So what I have to do is remove the return type entirely and use this syntax, which again is modifiers followed by the type that we're defining the constructor for, followed by a list of parameters, followed by a body.
And this point right here might be a good time to go ahead and start demonstrating parameters, because you could still have a problem at the moment with the way that students are instantiated, because you can instantiate a student, and what if you don't ever assign it a name? But all students must have a name. I mean, it only makes sense.
Right, and I'm actually going to emphasize what Jason just said, that all students must have a name. In a few minutes here, I'm going to step back and talk about some conceptual things about OOP. But in this case, we are saying in English that our student object or no student object should be valid without a properly set name. So how do we enforce that constraint? Well, the first problem is we are allowed to set the name to whatever we want. We just had a good question.
Yeah, the private one? Yeah, we'll get to that. We'll talk about that in a few minutes.
Okay. We can set the name of any student to whatever we want at any point. We can even set it to null, which really shouldn't be possible. We can set it to empty string, but again, that doesn't really make any sense either. So we don't want our name to be able to be set to null or empty string. There's one way that we can enforce this, one way. And that is by making the name field private. Now, currently the name field is public. The public access modifier is a modifier that you can attach to any member of a type. The public access modifier indicates that this member is accessible, meaning it can be used and modified by any other type in the program. The private access modifier means that this member can only be accessed within the context of the object itself, which is exactly what we want here. We really want that behavior here because we want to be in complete control over what people set our name property or our name field in this case, but more generically our name attribute to, our name state. We want to be in complete control of that. We don't want to allow other developers or yourself down the line when you have forgotten all about this program. We don't want it to be possible to set this name value to anything without asking the student class to do it for us. So we made it private. Now, because we've made it private, there is one thing we need to do here. And the one thing we need to do is we need to change the casing of it. Now, the different members and the way that you case different members according to the standard and according to the way most people write code, or the vast majority of people write code in the C# language, is very complicated, or I guess you could say relatively complicated. You get used to it over time, but it's something that has a lot of rules to it. And the type, or sorry, not the type, but the kind of member and the accessibility of the member are the two major factors into determining what naming convention we should use for that member. Methods, whether public or private, should always be Pascal case. Fields, if they are public, should be Camel or Pascal case. If they are private, they should be one of two things. So this is going to get into a nice little interesting discussion. Actually, something that Jason and I don't necessarily think we disagree on this as much as...
We don't disagree on it. It's just me, from a teaching perspective, I've always tried to teach whatever rules are set forth by, be it, Autodesk with Maya or 3ds Max, or in this case, Microsoft with a particular naming convention.
And in that case, the difference in naming convention that we're referring to is the difference between a camel case private field and a private field with an underscore preceding a camel case name. Now, because it would be so incredibly ridiculously painful for me to teach an entire course using a different naming convention than what I've been using for many, many years, I am going to be using an underscore followed by a lowercase. And I do have some reasons for this. I think it makes some things easier, but again, it's a personal preference sort of thing. And just to reiterate, the C# naming guidelines specify that you should have no symbols preceding a local private variable.
Correct, and that's the only thing that, the only reason when I teach, I don't teach with the underscore. But we've been using it like crazy with all of our development stuff. Underscore.
Yeah. So, okay, so we've solved two problems so far. We've made our field private, and we've changed its name to an appropriate name for a private field. But we have a problem here. How do we set the name? Now, we did rename it, so I could just go ahead and say, well, fine, because we renamed it, let's go ahead and just do underscore name now. But we'll run into a problem. We'll get in console application 1.student.underscore name is inaccessible due to its protection level. The protection level of a member is determined by its access modifiers. And because we've specified a private access modifier, this member is not accessible from any other type outside of itself. So, how do we fix this? Well, a parameterized constructor. Now, we've specified that the design of this program in such a way saying that students should always have a name and their name should always be valid. The only way to constrain that, not constrain, but the only way to enforce that is always 100% true is to force everyone to supply the name with the constructor. So you see, I just created another constructor. I made a student constructor. I gave it the public accessibility modifier, and I've also given it a parameter, just like we do with methods. And with this parameter, I can go ahead and say name equals name. So I can go ahead and assign the private state of my student to whatever initial state was asked for during the construction process. So what we can do now is if we go back here and we delete these parentheses and open them back up, you'll see that the tooltip that pops up actually tells us that we need to pass in a string name. Let's go ahead and do that.
Now the code's starting to look much better.
Yep. Not only did we enforce the fact that the name cannot be changed and a name must always be supplied, we've also cleaned up the code significantly. And we can take the same behavior and apply it to our course type as well. Or would this be a good exercise for people? Or is it too simplistic?
I'll let you make the call on it.
Well, I mean, I already did exactly what I'm about to do. So
Yeah.
Okay, so I'm gonna give the same treatment to our course class. I'm gonna say private string name. I'm gonna rename it to be appropriate. So that also means that on line 41 here, I'm going to have to change this name reference to an underscore name reference because now we're using the field that we just renamed. In addition, I'm going to give the constructor a required parameter called name. And inside of the constructor, I'm going to simply set name to name. So now you'll see two great things on main. First of all, we can't instantiate courses like this because courses require a name parameter. And second of all, we cannot change the name of a course once it's been instantiated. So I'm going to go ahead and do this. Wyke, that's a good question. We're going to definitely be getting into that very shortly here. Rich actually brought up a good question. He asked if we were using the normal, the other naming convention for private variables, then line 14 becomes problematic. The reason line 14 becomes problematic is because the parameter naming conventions are the exact same as the local field conventions. Now, the solution to this problem is not to annotate the parameter in any way. So if I were to say name 2, that would allow me to write this code properly, but it would look ugly. If I were to say underscore name here, that would allow the code to work properly, but it would be equally as ugly. If I were to give it another name entirely, the name of the student, now we're just getting ridiculous. The proper way to handle the ambiguity between the parameters and the fields of the same name is to use the this dot syntax. Now, this is very special. This is a variable that's going to be available to us on every single instance class in any instance method. And it's going to be a reference to the object that we are working with. Okay, so just keep that in mind. Alrighty,
So that's good for constructors. So from here, are you ready to introduce some properties?
Yeah, I do want to take one step back though. And I kind of, in the Monday class, I started the entire discussion, or started the entire class with the following discussion, which I'm not going to get very in depth into. But now that we have actually a little bit of context to work with, we've talked about what classes are, what objects are, how objects relate, and how objects get passed around, and how objects are constructed, and how accessibility modifiers work. Those are all specific tools that the C# language gives you to express your program. All a language is a bunch of tools that allow you to express the logic that you want to perform. Object-oriented programming is all about looking at the real world, identifying something in the real world that you want to perform. You want to represent or approximate or model a subset of the real world in your program. Now, obviously, if it were possible to, and I don't know why it's cut off there, that's really annoying. Oh, come on. It's not possible to model the entire world. It's not, in that case, that wouldn't be a model, that would be a perfect simulation. It's not possible to do that. So what we're stuck with in the land of programming is approximating the real world in a way that allows us to accomplish a goal. And all object-oriented programming is identifying certain aspects of the real world that we want to model. We want to model specific parts of the real world. And what we do is we model these in the concept of objects. And we give objects responsibilities. We give them state they contain, behavior they can perform, relationships between each other. And most importantly, we give these objects what are called invariants, rules that the object must continue to follow to be considered valid. A student without a name is not valid. It shouldn't be possible to create a student without a name. That's why we introduced the constructor here. And therefore, a student without a name, or a student not being able to exist without a name, is an invariant that the student object or the student class and the objects created from that class must enforce. And so it's really important to think about object-oriented programming as taking a limited portion of the world and approximating it using the tools that the C# language gives you, one of which is classes. And that's really all you're doing. You have to decide as an architect what parts of the real world you care about, what parts you need to accomplish a goal, how in depth you want to get that information in. For example, this program, the model that we have here, although the program isn't complete, but we can use a model like this to represent the courses that C++ does. Each one of you guys would become students, and each one of the courses we do would become course objects, and we could add you guys to the courses and keep track of that information and stuff. But the important thing is we chose when designing this program, as in the random characters, or Jason telling me to type in random characters earlier in the show, or in this class. It wasn't as much of a design as it was an example. But in designing this application, we decided to approximate the idea of a student in a course. We're not going to put how many pets you own, because that's not relevant to this model or approximation. We're not going to put any other aspect that we don't care about for this particular piece of this particular puzzle. So I just want to point out, that out. That's a way to think about object-oriented programming. The way to think about what we've accomplished so far is thinking about this as an approximation of the real world. And we get to make up the rules as far as what we care about, what invariants we enforce, and what behaviors we allow other people to invoke on.
I feel like we should all stand up and clap for you now. It was like Nelson's monologue. Very nice.
I mean, it made sense,
It did,
right?
of course.
Okay. I thought you were making fun of me.
No, not at all. So properties.
Okay. So in C#, when we have these classes and we want to enforce these particular invariants, we really don't want to expose our state publicly. And as a result, we generally need a way to acquire the data within our state and to set the data within our state. For example, there's no way to change the student names after they're instantiated. Now, that could be something we do want to model. That would be a useful thing. We want to be able to change the name after they've been instantiated, but we don't want it to be able to change their name to anything that the caller wants. We want to lock down that code. Now, I want to point out a flaw with our current program before we get into properties, because this is specifically a problem that properties solve. I want to point out a flaw, and that flaw is we can pass in null into the constructor. We can pass in null, and we can pass an empty string. And if you remember earlier, I specified null and empty strings were invalid characters or invalid names. I could also put in tabs and spaces and new lines and all this stuff that I don't want as a student name. I don't think that's useful, and I want to make it so it's impossible for people to create students with those names. So the way I would do this, actually, is inside my student class, I could simply say, inside my constructor, I can say if string.isNull or whitespace name, throw new argument exception. By doing this, I have now made it impossible to instantiate a student without a valid name. So that's very, very, very important, a very useful use that was a stupid sentence, but it's true. A very useful use of exceptions right here, where we're enforcing this invariant. But the thing is we cannot enforce this invariant if we were to make this public, or this field public. So let's go ahead and make this program valid again. And let's solve this problem. And the first problem is we want to be able to change the name of the student over time. So the easiest way to do that, and in fact, something that someone suggested earlier, which I didn't get to them specifically, but I'm now addressing this. They said, well, will you need a method to set all your fields now? The answer is actually yes to that, but there's a nicer way of doing what I'm about to do, which we'll get into soon. So if we add a set name method to it and use string name, we can say if string.isNull or whitespace name, throw new argument exception. If not, name equals name. And then I could even refactor this constructor into simply invoking set name. So now I'm kind of consolidating how I am able to set my name and forcing it to go through this funnel, which will validate that the name is correct. So at this point, I can actually set my name after I've been instantiated by doing Nelson.setName. But if I were to try to set it to an invalid name, I would get an exception, just like what I want. This object is enforcing the invariant that the name should be valid at all times. So that's for controlling how to set variables. But what if we wanted to get the name out of the Nelson object? Well, we could do just what we did before. We can say public string get name. And we can say return name. And now we can say set name to hey there, and now we can say Console.WriteLine Nelson.getName. So now if I run this program, you'll see hey there is being printed as a result of line 74. So I've effectively exposed my field, but in a way that allows me to make sure that nobody's doing anything stupid with my data. But Rich asked a good question. He's asking for the isNull or whitespace method, he's asking if hey there should be invalid because it has a space in it. Well, the reason it doesn't is isNull or whitespace checks to see if what's passed in is null or if it's entirely whitespace. So if it was just spaces. Hey there was printed 3 times. Yes, hey there was printed once up here because of line 73, but then because I added myself to both of the courses, it was also printed on line 85 and 86, as you see right there. If I were to comment out these two, just make this a little clearer, I could run this again and you'll just see the one hey there. Does that make sense? As you see on line 74, I'm console.WriteLining out the result of Nelson.getName. All right, cool. So this is ugly and annoying. And it's what people have gotten used to doing for a very long time. C++, this is the best way to handle this situation. Java, this is the best way to handle the situation. Possibly even more languages, but those are the two ones that I can think of off the top of my head that will force you to write code like this. But C# noticed, the designers of C# noticed that there are very common patterns that people use quite often, and they actually turn that into a piece of syntax that we can use to save ourselves a lot of typing and a lot of headache. And the feature that I'm about to show right now is what are called properties. A property is a member on a class that allows you to define 1 or 2 methods on it that correspond to getting or setting a piece of data. And the way we define properties is very similar to how we define fields. It's basically defining a property is a combination of defining a field and defining 2 methods at the same time. at least as far as how the syntax looks. If I were to go ahead and start my property, I would start with the public access modifier because I want this property to be accessible to everyone. I would give it a type. In this case, it's going to be string. All properties have types. Then I would give it a name or an identifier. In this case, I'm giving it the name. And you'll notice that my casing is in Pascal case because it is a public property. The next thing I'm going to do is a little weird. I'm going to open up some curlies. And the reason why this will look very strange is I don't have parentheses right here. In fact, this is so similar to a method definition that I could simply add parentheses right there and, well, and I would have to return something, of course, but I could turn this into a method by simply adding parentheses because it's so close to that syntax, but it's not. It does not have parentheses. However, what goes inside of it is very different from a method. In fact, what goes inside of it is one or two methods, but using very strange keywords. The first one I'm going to show is the get. So inside of the parentheses that you have, or sorry, curly braces that you have in a property, you can put the get keyword in. And you can type in the word get and follow it with another block. Now, here's the cool thing. This block is a method. In fact, this block's method, this method right here, which is a method, has the exact same signature as what we have up here. Now, the reason it knows that this is the signature is because the public modifier is up here, and the return type is right here. What I can do inside of this method is I can say return underscore name. Oh, in fact, I could really do whatever I wanted right here. I could say return derpy if I wanted.
Ooh, derpy.
Or Console.WriteLine, whoa, you know, I can put whatever I want inside of this particular method because it's really just a method. I'm not going to be pressing F5. So the point here, though, is that this is indeed a method, and this method has a return type, and we can return whatever we want. So I'm going to go ahead and return what we should return in this case, which is going to be underscore name, meaning that it has basically the exact same body as our getName method. In fact, it has the same signature except for the name with our getName method. For all intents and purposes, what we've defined here is a method that returns our name. But here's where things get cool. If I wanted to access the name property, I no longer have to do Nelson.getName. I can simply do Nelson.name. And you'll notice that the symbol right here actually changed. It's different than the field symbol. And it's different from the method symbol. And by typing in Nelson.name without parentheses, that's important because although it is a method, it's a very special method that has special syntax in the language. What actually happens is we are invoking the getter, and we are getting the result of whatever the getter decided to return, which again is absolutely arbitrary. In this case, I did do this properly by returning underscore name. So as a result, when I run this program, when we get to line 80, you'll see that the proper name is displayed to the screen. If I were to say, just to enforce the fact that this name property and this name field have no correlation to each other by default, I can return a constant if I wanted to. And you'll notice that I get returned to me ASDF. But returning back to making this, the proper implementation, I'm going to go ahead and figure out why my full screen is doing that because it's really, really bugging me. Fine, I'm just well, whatever. You win Visual Studio. I'm not going to use full screen. I'm going to go ahead and fire up a new window and highlight this, and I'm going to go ahead and go over here and highlight this. So Are there any questions about this? What I just showed? Are there any questions about a property and a property having a getter method attached into it? Again, this is just special syntax over the concept of having a method that simply returns our data. Instead, we have a property that returns the data. White, that's up next. There is a setter. Well, if everybody wants the setter, then they must be good with the getter. Buzzcat, I actually kind of do know the keyboard shortcut for full screen. The reason I do is because I accidentally hit it all the time. I think it's like, isn't it like Alt Enter? Yeah, it's Alt Shift Enter. But I rarely go into full screen. I've only gone into full screen for the purposes of this course. But because of the way ReSharper shortcuts work, I always end up accidentally doing that, and it's really obnoxious. Wow, everybody just wants to learn about setters, I guess.
I came for the setters. That's awesome.
Oh, there's your setter.
He's been waiting all night for the setters.
Actually, I want to back up a second. So you saw how, well, no, I'm talking about setters now, but so you saw how Console.WriteLine Nelson.name, that invoked the getter. To invoke the setter, we simply, well, set it to something. But here's a problem. Because we don't have a setter on this property, we're going to get a compilation error saying property or indexer student.name cannot be assigned to. It's read-only. So let's go ahead and attach a setter. So again, to invoke the getter, we simply use the field or use the property in some sort of expression. To invoke the setter, we assign the property to some sort of expression using the assignment operator. So to add a getter or add a setter, all I have to do is type in the keyword set followed by a block. And as of right now, this code is correct. Can anybody guess the output of this program up to and past 81 or immediately after 81? Look closely at lines 13 through 17 and look closely at lines 75 through 81. We just get Nelson.
Ta-da!
So what's happened here is we've defined a setter which makes this syntax valid, but there's no implementation in our setter. There's no code in there. And remember, just like the getter, the setter is an entire method. We can place any bit of executable code that we want inside the setter. But what we really want to do is we want to set the name variable to something. And to do that, we're going to go ahead and say name equals, and then wait a sec. Now what? Remember, the setter is a function, and we know that a value is being passed into the setter function, but there's no parameters. There aren't any parameters here. What the C# language designers did was they invented a special value inside of a setter, not surprisingly called value. And value is a keyword. And inside the context of a setter, the value variable is going to automatically, magically be set to whatever we assign the property to. So now what should the output be on line 84? One of these days it is going to be Rainbow Dash, and I'm totally not going to expect it. Like, that's going to be the best day ever.
You'd be like, that's it, class is over for tonight. I need a drink.
Okay, so we've successfully created our setter, but we have a very big glaring problem with our code as it stands. Can anybody guess the big glaring problem with our code as it stands? And people have been saying no validation, no verification, and stuff like that. And that's true. If I were to set my name to blank and use my property to get it, notice how blank gets printed out. But I already identified that a blank name is invalid. I don't want that to happen in my code. So what I'm going to do is I'm going to retire these two methods because we've effectively replaced these two methods with these two methods. So I'm going to nuke them. And I'm going to yank the validation out of the setName method, and I'm just going to delete the setName method and rewrite it inside of our setter. So I'm going to say if string.is null or whitespace value, throw new argument exception. And then on line 29, instead of saying set name, I'm going to say name equals name. Is the only time the value keyword used in the setter? I'm pretty sure it is. I've never seen value used elsewhere. In fact, I could have sworn it was even more than that, value is a contextual keyword. C# has a variety of these contextual keywords that are only keywords in certain contexts, which the name contextual keyword would imply. And value is one of them, meaning that value is only considered a keyword when in the context of a setter.
Ooh, Rich, it's a good question, but think about what you just asked. Rich says, why wouldn't you just set _name since it is in the same class? If we just set _name, what happens to our validation? So if somebody passes in a null, and then we directly set that, because setting a field is just a variable that's going to hold information. Properties can contain logic. Okay, good. Yeah, you see, good deal.
Yep. Well, actually, more specifically, properties are logic.
Yeah, absolutely.
Meaning that a property doesn't necessarily have to, in any way, reference a field.
Yeah, exactly. It doesn't have to set anything. Like you could have an inventory system, and you could have a property called weight. And if you asked for the weight, what weight could do is go through a list of all the items that the thing contains, add up all the weight of each item, and send that back. It's not referencing any field.
Yep. Alrighty. So are there any questions about getters and setters? And I want to reiterate the fact that these are methods. In fact, the CLR itself, or specifically intermediate language itself, has no concept of properties. Properties are a special magical thing that C# and most other .NET languages, in fact all other .NET languages if I'm not mistaken, respect. But it's not an actual concept inside of the CLR itself. These are literally compiled into two methods, a getter method and a setter method. I mean, are there any questions about properties?
So there's one last thing that I'll get you to talk about before we talk about homework.
Why does this class feel so short?
You've done an excellent job. This class has actually been packed with more information than the Monday class.
Ooh, I guess ask a question. Throw new argument exception will crash the program unless it's unhandled. And if you need a refresher on handling exceptions, we did a course on it 2 weeks ago, or was that last week?
Something like that. Yeah, last week.
But in this case, see, here's the thing. If anybody tries to set my name to null or white space, I consider that a bug. And that's a very important, that goes back into the philosophy of object-oriented design, where if you break that invariant inside your code, then you should always just throw an exception, throw up your hands and say, no, I'm not going to do this anymore. As a result, if I were to accept input from the user, I would validate the user prior to actually instantiating my student class, so that I'm not telling my code to do something that is wrong. I think we talked about casts.
Yeah, we have. So the next thing I want to get you to talk about, Nelson, is, and not a long discussion on it, but just static.
What about shorthand?
Yeah, you can go ahead and show automatic properties.
Alrighty. Oh, private constructor.
Oh, yeah, thanks, Rich.
Let's do that real fast. Private constructor. The answer to your question of can you have a private constructor is yes.
In this case, will it break the world? Yes.
Yes. By making this constructor private, remember that the default constructor C# generates, which is a public, parameterless, empty method, is not going to be generated if any other constructor, public or private, exists on the class. As a result, the only constructor on this class now is a private constructor. As a result, we cannot instantiate any of the classes outside of itself. Which we have not talked about static yet. That's what we're gonna wrap up with. So why would you ever want that?
What if you wanted the object, in this case course, itself to handle its own instantiation and hand an instanced copy of itself back out to whoever asked for a copy? Nelson, you want to set up a quick method? I'm not looking to create a singleton. I'm just looking for it to manage its own, like its own internal factory or repository.
Well, I'll need to use static for that.
I know.
Okay.
I mean, we're wrapping up with that, and we're right here at the very end. Patterns 101, only at 3D Buzz. That's right, DF.
So this would be an example of something that we would be able to do. But this is a static method that we haven't quite talked about yet. But what's going on here is we have created a little factory method, or a method responsible for instantiating another class, but we placed it inside of our own course class. And the reason we had to do that is because the course constructor is private.
So let's go ahead and update lines 81 and 82 real quick, just to make the program compilable again.
Yeah, in this case, it would be course.createInstance and course.createInstance.
Notice how we're no longer using new.
Yep. Well, we are, but indirectly.
In lines 81 and 82.
Yeah, in line 81
Remember,
and 82,
look
we're no
at
longer using
if we're outside of the class, like in this case, we're over in the class program. Look at course as just being a black box. So we don't know what's going on inside, but we're not using new ourselves.
Now, this sort of pattern is not very useful in this case, but there are times where you will find yourself doing this. Alrighty. So, there was a question about public and private constructors. Somebody asked, what?
I didn't say anything.
Is that you, Jason? Oh, I heard you say something.
Didn't say anything at all.
Or no, try to say something.
I didn't try to say anything. Voices, Nelson. Voices.
Somebody asked, maybe this is a dumb question. It's not, but can you have both a public and a private course constructor that get called if they're called internally or externally? The answer is yes and no. You can have as many constructors of varying accessibility that you want, as long as they follow the exact same rules as method overloading. Meaning, I could have a public course constructor that takes the name, and then I could also have a private course constructor that doesn't. And then I could have another public course constructor that takes in an int age for some reason. That doesn't make any sense. But the point is that constructor overloading follows the same rules as method overloading. And every overload gives you the opportunity to specify the accessibility level.
And something just came in over on the questions panel, Nelson.
You may have talked about this, but do the new classes have to be before main program class or after main? Good question. The answer is in C#, there's no concept of location or order of either members or types, even between files. Unlike some languages that like to take forever to compile and result in bloated assemblies, or sorry, executables because they're native, and having to deal with the absolute horridness that is the include preprocessor directive, C# is not like that. Every single type and every single member of every single type is accessible simultaneously from every location within the program. Okay, so, and I was talking about C++, WAG, or C, because they do require that you specify things in certain order, because their compilers were made before computers had enough memory to hold the entire metadata of a single program at once.
And Flash, I know you feel stuffed with knowledge, but hang in there. We got just a little bit more to stuff in for tonight.
Alrighty, so automatic properties. Well, a lot of times you have an instance where I'm going to go ahead and remove conceptually the validation constraint of our name. So from now on, our name is considered to be valid if it is null or white space. I'm not really bashing it, and I'm not going to bash it during the C++ course
because you don't want to get lynched.
And I don't want to get lynched, and I think it's a good language, and I think it has its uses, and I think it's an important language to learn specifically, even if you end up not using it professionally. But it kind of my running thing is that C# has a lot of productivity features that C++ does not. And I like pointing those out when I get the opportunity to, so people have a broader idea about the differences. And Lisp is fun, TF. Don't knock Lisp. Okay, so this pattern.
That's common.
Is incredibly, incredibly, incredibly common. It happens so frequently that the C# language designers eventually came up with a way to make it considerably shorter. This code, I'm going to go ahead and comment this out, because I assume everybody understands it up until this point. But if I wanted to write a piece of code that had the exact behavior as lines 11 through 17, I could simply create what's known as an automatic property. So I start off the definition just like normal. I give it the accessibility modifiers. I give it the type. I give it the name. I open the curlies and I close the curlies. But inside of the curlies, I put something different.
Ta-da.
So in this case, we have effectively made code a lot shorter. And as you notice here on our display method, we have to update our reference to use name. Behind the scenes, this code is being generated. So I just want to point that out. In addition, there are a few rules about automatic properties. One of the rules is you must have a getter and you must have a setter. You cannot have an automatic property with just a getter or setter. The second rule is automatic properties are all or nothing, meaning you are either using an automatic property or using the longhand property syntax. The third thing, just like with the syntax up here, which we didn't cover, but you can also add accessibility modifiers to each one of these methods individually. And these really don't look like methods. They especially don't look like methods now, but they really are. And we can actually update their accessibility to whatever we want, meaning we can give this a private setter so that we will actually disallow setting this property outside of the class. So it's very interesting. And again, I'm not going to be talking about the fact that we have just lost our validation, because we have. There are ways that I deal with that scenario, but that's going to be probably covered more in 102 and beyond. For now, I'm just going to leave the validation out. There are some things in the class on Monday where I did talk a little bit about that, so you can refer to that video back then. Brian asks, does the underscore name field still exist? The answer is, well, yes and no. Again, which is pretty much the answer to everything. The underscore name field doesn't exist as an underscore name field. In fact, it doesn't exist as anything that we can access within C# code. There is no way for us inside of C# without using reflection to access that field that is being generated behind the scenes on line 19, but it is there. It's just completely 100% hidden. So yes, it still exists, but we cannot access it in any meaningful way. Okay, Jason, time me, 10 seconds.
Go.
You ready?
Go.
Reflection is the ability to invoke code dynamically during the execution of a C# program. So it's something that you can use to look at types and methods and properties and fields. Okay. Alrighty, so okay, so we now have automatic properties behind us. Does everybody understand automatic properties, the concept of changing the accessibility of the set property as well? All right, sweet.
Okay, static.
Kind of feel that a diagram would help in this case, but I don't want to drag everything out too far.
No, you don't have to. All you got to do is just point to Console.WriteLine.
Well, yeah.
I mean, static's easy.
Well, it is, but it gets a little bit more complicated once you start talking about it in the context
It's a 101
of...
class. You don't have to dig too deep.
Well, of your own types. But everything in C#. Wyke asks, actually, can you do private string name with a public getter? And the answer is no. This actually has a distinctly different meaning than a public string name with a private setter. So I just wanted to point that out really quickly. The accessibility of a property is always going to be, by default, the accessibility modifier you specify, and then you are only allowed to set or override the accessibility to an accessibility level lower than the accessibility level of the entire property. Okay, so static. Everything in C# is in a type. Everything in C# is in a class or a structure or an interface or a delegate or an enum or whatever. There's no way to write code that's outside of a type. Generally speaking, the only two types that you can insert executable code into are structures and classes. And again, we're not going to be talking about structures, so let's just leave that as the only executable code you can place anywhere in C# is going to be inside of a class. Just think of that for now. Ignore the fact that structures exist. So how do we, I mean, that makes things a little complex though, because if everything needs to be in a class and we need to instantiate classes in order to use them, How is it possible that we can do Console.WriteLine? In fact, doesn't that mean that when we invoke the program, the main or when we start the program class is instantiated and the main method is invoked on that class? And the answer is no, because the concept of staticness. Staticness allows you to access members without having to create an instance of the type you're accessing members for. So for example, in the case of your program starting up, the program class doesn't get instantiated because it doesn't need to be. Because the main method is static, it can be invoked without instantiating the programming class. In fact, we can prove that the program class is never instantiated by giving it a constructor. As you see, line 55 never executes. Program is never instantiated. And the reason that it never gets instantiated is because, the reason it doesn't need to be instantiated is because the main method is static, just like how the Console.WriteLine method is static. Console is a type. And in fact, console is a static type, but we're not getting into that. Console is a type. It is a class specifically. If you hover over it, you'll see class System.Console. And it has a static member called WriteLine. And we can invoke this method wherever we want. We do not need to instantiate the console type in order to gain access to that method, because it's static. And a static member exists outside of all the objects that are created from that class. Does anybody have questions about static? I know that was a very, very rough overview. Maybe too rough.
I mean, it's pretty straightforward, though. I mean, the bottom line is if we happen to need some sort of functionality that exists in a class, that would not make sense for that functionality to be instanced functionality. And a good example is WriteLine. It doesn't make sense to have to instantiate console in order for us to get an instanced method called WriteLine so that we can write something out to the console.
And then another good example would be the math class. You'll notice math is a class, but we don't need to instantiate it to access any of its members because all these members are static. So the method is static, but what about the class? Is that static too? It is, and I guess I could briefly. Okay, a static class is a class that can't be instantiated. There you go. And yes, console is a static class, meaning there's no way to new up a console, or there's no way to instantiate a console. Is everything passed to methods as a reference except for variables like int, string, bool, etc.? That's a good question. The answer is mostly. Integers, booleans, doubles, decimals, all of those are made of structures. And I've been purposefully avoiding what a structure is or how it behaves, but one of the behaviors of a structure is that it is passed by value, not by reference. I do want to point out, though, that strings are reference types, meaning a string is a class. It isn't a structure. Strings are actually passed by reference. However, strings are immutable, meaning once you have a string reference, you cannot change that string. There is no way to, for example, if I had a string, my string, this is a reference. This constant string gets allocated. It doesn't actually get allocated on the heap. There's some special behavior with that. But the point is that this variable is pointing to a reference for this string. There is no way for me to edit the contents of this string, period. I cannot do my string 0 equals 2, for example. That's impossible. There's no method on this string that'll let me edit it. But what I can do is I can reassign the string variable to another string variable. So I want to point out that strings are passed by reference, but because there's no way to edit the data inside of a string, they're effectively semantically passed by value, I guess you could say. Like, no.
And
we have not gone over the string array args.
And we're not going to in 101.
Brian, did I answer your question? Because it is a very...
Yeah.
Okay.
And no no reason to be sorry, Wick. It's all good.
Okay.
Okay. Start talking some homework.
Ooh, Barry points out something important. I want to point out earlier when I gave my huge monologue about the fundamentals of OOD, I did say that our purpose for creating classes is to make a representation of the real world. But I want to point out that don't be afraid to create classes that don't actually correspond to a physical thing. For example, let's say I wanted to create a class that read in a list of students from a file. And I don't want that functionality to be inside the student class itself. I want it to be in its own class. So I can make a class called StudentLoader, which has no corresponding
real-world entity.
Real-world entity. It's just a thing. It's a concept that I created myself. And you're allowed to create those concepts, as many as you need to accomplish a goal. And I can give this a method such like list of student load students from file string file name. And so now I made a class with a because I'm not returning anything. Now I made a class that doesn't have a real-world corresponding entity, but it does perform behavior that is useful, and it does perform behavior that is useful to segregate into its own class. Are classes public or private by default? They are neither. Classes are internal by default, but we haven't talked about the internal modifier yet. That's going to become more important once we start talking about multiple class libraries in the same project, and especially more important once we start talking about multiple files within the same project. Alrighty. Homework.
Now, Gavin is not with us. He's snoozing right now. But
according to
you can grab the link.
There we go. Okay, so the homework is going to be refactoring the product inventory system that you created in the previous homework using object-oriented techniques. Now, I know that's such a broad prompt, so I gave some very specific requirements and suggestions for actually accomplishing this. And the first one is that the only method in the program class must be main. So, this is the only method that you're allowed to stick in the program class. The next thing, prefer separating the following concepts: storing product data, reading product data, writing product data, getting input from the user, displaying product data. When I say separating, I mean breaking into classes or one class or multiple classes. Next constraint, no more than 25 lines per method, not including comments or white space. The reason I put that in there is because some people have been using comments to remind themselves of certain language features, and then I also didn't want to encourage people not using proper white space just to squeeze more lines into their method. But yeah,
it's that simple.
Is there a benefit to splitting classes rather than using multiple methods? That's a good question, and it really depends on the scenario. It really does. That sort of question is something that you're going to get an intuitive feel for the more you use object-oriented programming, because both splitting classes and using different methods, really depends on what you're trying to do, really, and each approach has its own trade-offs. No, the curlies are not included in the line limit. So I guess I can go ahead and just
update it.
Yeah, there we go.
Sweet. This is going to put us right at 3 hours of recorded content. Very good class, though. Outstanding job, Nelson. Whiteboarding and all. And no, Wick, no one really long line.
Yeah, so how did everybody like the course? Because this is it, really.
That's true.
I mean, obviously we'll be turning around doing 102 very shortly, but
and we'll be wrapping this up next week with a test for everyone. That's
yeah.
But for a 101 class, I feel it was very successful. And very excited about 102. Well, thank you guys. You guys have all been awesome students. And I guess we'll go ahead and wrap things up tonight. Please make sure to watch the calendar tomorrow. I'll try to get up at some point tomorrow for the days that we'll be meeting next week. Again, I'm going to have multiple days in order for those of you that are going for the certificate to take your test. And a good question that just came in, will the video stay available online after the class is completed? Yes.
Yeah, they'll stay. I mean, as long as you're a member sponsor, you'll have access to all the course videos from, well, all the courses indefinitely.
And if you find yourself bored and you didn't see Monday night's class, you can watch that one and get a different perspective on the same content. Nelson played with cars that night. That's why I wanted him to do something different tonight. But I think tonight's lecture turned out way better, much more detailed, and there was whiteboarding.
Well, an attempt at whiteboarding.
Oh, come on. It looked fantastic. I'm just curious real quick what Wick put over in the...
Yeah, I'm trying to copy that.
But just don't, make sure you don't put that in. Nice. But we'll go ahead and wrap the class up here. So I'm going to stop the recording. Those that are watching, thank you very much for tuning in tonight, and we're out of here. Goodbye, everyone.